Very much for the opportunity to speak here today. I would like to talk to you today a little bit about the things we do at Technetix. So we are a new partner of HFC Technetix, and we've basically for 30 years specialized in HFC developments and manufacturing. And basically we always try to think a little bit outside the box, try to innovate. Even now we are still one of the few companies that really invest a lot of money into HFC developments. New technologies, but also innovations on existing platforms like the DOCSIS 3.1. First, I want to talk a little bit about DOCSIS, speeds, what are the important parts currently in the DOCSIS plans, and then about what can we do to improve using artificial intelligence, which we have a very interesting project. So I'm Maarten Markhorst, Director of Product Management, Technetix Worldwide. Yeah, this is my presentation about the future of the HFC networks, basically. So, of course, there's a lot to do about DOCSIS versus fiber, and we're mainly talking always about speed, right? We just saw it on the slide as well. Yes, with DOCSIS 4.0, we can reach much higher speeds. We can go 10 gigabits. With DOCSIS 5, we could go 25 gigabits downstream. But if you look at the fiber speeds, in the end, on speed, we're going to lose from fiber. So, is that really the most important thing? That speed, the gigabits per second. If you look at what you really need at the moment, you see that most of the demand, the downstream demand, is driven by video. You need about 15 Mbit per second to do a 4K video stream. Let's say you have a very big family, 10 people, all streaming at the same time. You don't really need 10 gigabits at this moment. You don't know what's going to come in the future. It's always good to be ready, but there is some capacity there that is left over, basically. If you look at what people really look for when selecting an operator, it's not speed. It's only about 7% of the decision-making process. It's about reliability, cost, and network quality. Those are the key things that will convince a customer to go to an operator. To talk a little bit more about this focus, one of the products I'm showing here is basically our most popular amplifier platform for HFC amplifiers. And we launched this 14 years ago now. And basically it was a huge innovation back then to make the amplifier modular so that you can easily swap and maintain without having the plant down for too long. You can hot swap, for example, a downstream module in just a matter of seconds when it's broken. You can swap the power supply instead of having to swap the whole amplifier. So you can actually improve your cost base, you can improve the quality of service of your network. These amplifiers are in fact ready to go to DOCSIS 3.1, so you can upgrade them from low split to high split. And you can see that basically that means that if the bottleneck at the moment in most operators is the upstream. People are using more FaceTime, people are using much more upstream data than they used to, working from home, these kind of things. So what we see is that a lot of European operators, they are looking first to make the most out of the DOCSIS 3.1 network with 1.2 gigahertz products and upgrading to high split to increase the upstream capacity because that is where currently is the bottleneck in a lot of cases. So our amplifiers are already ready for that and they are very easily field upgradable to make use of that. So with this modular concept, basically the reliability and the quality of your network can improve. And these amplifiers also have a very good mean time before failure, so they can last very long in the networks. We have more than 1 million deployed in Europe and very low returns. So this is a good upgrade for your quality. But we're not only talking about the amplifiers, because these amplifiers they are smart because they are digital controllable, but they are also relatively dumb because you cannot really remote control them. You cannot really use them for the features that were just explained, as AI can help you to do a lot of cool things with the network, but these amplifiers are not yet ready. We at Technetix have been for a few years now working on AI basically in our lab. We hired a few very smart programmers that are playing with machine learning algorithms and AI algorithms. And And basically this project has come to a very nice lab trial, and our first algorithms are now in a prototype stage that they can actually do something quite impressive. So I want to take you a little bit on that journey today. How we connect the amplifiers and how you can actually, with the current plant, make an upgrade to make them suitable for AI. With the AI, in fact, what you can do is you can lower operational costs because you can, for example, send the technician directly to the right place, but also the AI can solve a lot of alignment issues, ingress issues, in fact. So say you can work much smarter, not harder. So the amplifiers, which we can also show you in the break time, they can be upgraded already with the DOCSIS transponder. So that means that the amplifier you just saw, you just put a DOCSIS modem in the lid, and then you can remote control the amplifier. All the settings are digital, so you don't have to do anything physical. You can control all the equalizers and attenuators, ingress detection switches remotely from your network management system. However, DOCSIS transponders are very expensive, and you have to have also the DOCSIS licenses. We need to pay them. So in fact, it's quite a costly solution to fit all your amplifiers with the DOCSIS transponder. So Technetix is developing the Neuronix transponder, which is based on the new SCTE standard that basically uses bidirectional FSK as a physical communication layer, and then a LoRaWAN communication protocol on top of that. That is in development, but it can actually be fitted the exact same way as a DOCSIS transponder. We can fit it in the lid, we insert RF signals in the same location, take power from the control module, and take control over the amplifier in exactly the same way. How would that ecosystem look like? So basically you fit all the amplifiers and in fact also the nodes with transponders. And basically the Neuronix controller controls all the amplifiers via the Neuronix ZMS. You need to insert that FSK signal in your head end if you have an analog node, but if you have a remote PHY device, you could in fact make that fully digital. So you don't have any physical device anymore in the head end. But if you have an analog node, you will need a physical device in the head end and couple the FSK signals on the main network. That's about the ecosystem. Now, let me show you what we built in the Netherlands in the lab. Basically, it's a setup where we have a cascade, a CMTS, an optical node, M+5, so 5 amplifiers. And you can see here modems hanging on here. I think there's even 20 modems in total that are connected, real cable lengths. And we use an American-style amplifier setup, so with trunk amplifiers and line extenders. So an M+5 is a pretty standard configuration, but in fact for the AI features, the setup doesn't really matter as long as all the amplifiers are connected, or even part of the amplifiers are connected, it will still function the same way. So what we did is we first focused on giving the AI control over all the EQs, all the equalizers and attenuators of all the individual amplifiers, and giving the AI access to all the modem data. So the AI knows what are the receive levels at all the modems, it knows what are the ideal receive levels at all the modems, and it knows what is the SNR, so the signal to noise ratio. Then what we did is basically we aligned it very roughly, almost out of the box. So just everything on standard settings, we just put it in, and then we looked at the modem receive levels. So if you look here, the top line is basically the max power limit. Then you have the power limit, the high power is 1 standard deviation from the average. Then the back line is the average. The middle red line is then the 1 standard deviation below the average, and then there is the minimum power level. Those are the modem receive levels. So you see a lot of modems, they are not well in this scenario. There's, I think, only the highest they get good quality signal. So then we leave the AI to do its cycles. So it's doing cycles every 5 minutes. It can do a few 1 dB per round, and it's doing 8 rounds per 5 minutes. So basically it cannot swap from 0 attenuation to 10 attenuation or to -10 in the amplifier. It makes small steps to make sure that the DOCSIS signal and the surfaces are not impacted. So it makes small steps, and it takes a little bit of time to see what is the best course of action. So I'm going to run you now through the steps, what it did. So basically, this is all AI. This is just the data that we collected. No human interference here. So there we go. So you see that by reducing the attenuation on the amplifiers, it brings it to the right level. So this is basically one day. The next day, we said, okay, we're now going to have the AI algorithm optimize this even further. So this is the starting position. You can see the scale change, that's why it moves a little bit. So basically, as a next step, because the modem receive levels want to be around 0, that was the target we put. So now in the optimization, it's going to run again. And you can see how the modem receive levels, how it gets it near to perfect. So this is really the power of the AI, because what you can in fact do is you can just install amplifiers. Your technician doesn't even have to know about levels, doesn't even have to know about alignments. It just have to put some standard settings that you pre-describe. You let the AI do its job, and it can basically align the whole network for you. So this makes it a lot easier to basically maintain and service the HFC network. And you can also imagine that with this automatic alignments, what we also try is, for example, making a mistake in your network, adding a splitter where it isn't supposed to be. Then the AI, with the amplifier settings, will try to adjust for the mistake made so that the end signal at the end user will be most optimal. So this effect helps you in the cost side, because it's much easier for installers to work, and you need a lower skill level, but it helps you also a lot in the reliability and quality of network service that you can offer. So there's a few things that we are basically doing with AI. The 3 use cases that we currently have working. So the first one I show you now is basically automatic alignment and adjustment. The other real big use case is ingress tracking, because of course we have a lot of ingress noise in the network, and this causes a lot of upstream issues as well. So also if you go to DOCSIS 3.1, you may have a little bit more spectrum, but you will still have upstream ingress noise coming from homes that is really difficult to solve. What the AI can do is something that humans can't, is that it tries to play with the attenuation of the amplifiers, and it finds the lag of the amplifier where the noise comes from and attenuates that, and it can attenuate it maybe by the optimal setting is 13 dB or 13.5. An installer will either switch it off or try to find the source. So what the AI will do is it will find the most optimal setting so that all the modems in that node are in the most optimal performance. So we can talk about this for a long time, I guess, but feel free also to come by later. I have some more details on that one as well. It's a real important feature, the ingress noise tracking and killing, because it's one of the key issues that most of the operators are experiencing, especially when troubleshooting the networks. So, the AI can track it and can kill the ingress noise, or it can say, this is the location where it comes from. You need to send a guy here because the noise is too bad, and I need to attenuate the whole upstream of this lag to make the rest of the network better. So then you know, okay, it gives an alarm and it says, okay, send your technician to this lag to solve the noise ingress. One of the other things, a lot of operators don't have proper maps of their network. So what is the topology? Which amplifier is behind which node? Which modem is behind which amplifier? In fact, what the AI can do with just a small change in the attenuators, it can really detect which amplifier is behind which amplifier and which modem is behind which amplifier. So it can basically detect your whole topology in a minute if you have everything connected, of course. That is my presentation about the AI features that we're working on. If you're more interested to learn more, feel free to come by at our table. We can discuss more. Thank you very much.